What I want to talk about is how the release reuse equivalence principle is used in conjunction with the rest of the packaging principles. Primarily, how it relates to the stable abstractions principle, and then eventually the acyclic dependencies principle. Ever come across a problem when you're refactoring code, specifically when you're shifting functions or methods from one place to another, and you end up with something really strange going on in your dependency graph? You're getting circular references. This can often be solved by moving towards abstractions, and that's where the stable abstractions principle starts to take effect. If you shift all your abstractions into one place, into one library, that can then be deployed and reused independently of any implementation. And that pushes you towards both the release reuse equivalence principle, i.e. you're reusing and releasing the abstractions as a separate package, and also towards the stable abstractions principle, because you're depending on those abstractions, so therefore they become stable. The implementations might change, and they can do so independently. And this is largely exactly the same principle and solution that we've used in hardware for years. Things like graphics cards have a base implementation. All graphics cards implement the same basic interface so that any PC architecture can talk to it and get a picture on the screen. We're depending on that stable abstraction and not the specific implementation. It's also possible to extend such structures by using further interfaces, rather than changing what you're depending on, adding a new one and then implementing that in conjunction with the original. Implementing a known base interface, and then you're also implementing some sort of extended feature set, which is also placed in an abstraction, distributed at the same time in the same package, or it could in fact be a separate package. This is the kind of thing you see with an abstractions version. That abstractions version is basically the thing you depend on, and then implementations can change when they need to. To attain this level of abstraction, you have to adhere to one rule. Everything in an abstract class can only depend on other abstract items, or at a pinch, things that are part of your base framework, i.e. Java SDK or the .NET framework. Because as soon as you have an interface or an abstract class depending on something even slightly concrete that's potentially outside of its control, you can run into some really, really weird problems. That means you're coupling everything that uses your interface to that concrete implementation, and that's likely to be inappropriate. There are sometimes occasions when you have to use something that's inside a third-party library, something that you don't have control over the implementation of. In some cases, those libraries will provide an abstractions version, so you can use that when depending on it in your abstractions. But if that's not the case, there is sometimes a valid argument to wrap that particular implementation in your own interface. This allows you to separate your implementation and your use of it from that third party's implementation. The advantage is that it may be possible to re-implement that at a later stage using some other library, should for whatever reason that third party stop supporting what you've depended on. So pretty much in summary, you can use these principles to try and protect yourself from third parties changing code that you don't have any control over. It helps you separate your code into something that's more testable and decoupled without running into circular references. It also means that implementations can change without massive disruption to things that depend on that particular abstraction, because they only have to worry about the abstraction and the implementation can be injected at runtime. If you've enjoyed this content, then please let YouTube and myself know by booping the like button. And if you'd like to know a bit more about these packaging principles and other object-oriented design patterns, then why don't you try out one of these videos next?